Welcome back to Think Thrice Problem Solving. Today we're going to be solving another integral. So this is the last integral of the 1 over x to the n plus 1 variety. And you'll realize why after we get started on it. It's a little bit involved. So if you'd like to pause the video and get started, you can give this a try, see if you can get through. Otherwise, we will go ahead and get cracking. So I see this integral, and obviously this would be easy if it was just 1 over x to the fifth, but this guy kind of complicates things. We have this 1 here, and that makes life just a little bit harder. So what we're going to do is we see that we have this x to the fifth plus 1 here. It would be nice if we could reduce the degree of that polynomial in the denominator. So we notice that negative 1 is a root of x to the fifth plus 1. So let's go ahead and do some long division. And let's divide out x plus 1 from that x to the fifth plus 1. So when we do that, we take x to the fourth. That gives us x to the fifth plus x to the fourth. We subtract that. It's going to give us negative x to the fourth. And we go through, we subtract x cubed. That'll give us negative x to the fourth minus x cubed. We're subtracting that. We'll get x cubed plus 1. Take that to x squared. It gives us x cubed plus x squared, which we're subtracting. We get negative x squared plus 1. We're almost there. Negative x squared minus x. We're subtracting that. We're going to get x plus 1, which is what we started with. So looking pretty good. So the reason we've done that is now we're going to be able to write our integral of 1 over x to the fifth plus 1, as instead an integral of some value over x plus 1 plus bx cubed plus cx squared plus dx plus e over x to the fourth minus x cubed plus x squared minus x plus 1. So we're doing some partial fraction decomposition. All right, so now we can go ahead and figure out what we're going to have for our equation. So we're going to have, if we multiply the left side by x to the fifth plus 1, we multiply the right side if we multiply the right side out, we're going to go ahead and get equations on the fifth degree term, fourth degree term, third degree term, second degree term, first degree term, and 0th degree term. And actually we won't have a fifth degree term. All right, so when we go through here, so we're going to start off with, on the left, all we have is our 1. So we're just going to have a 1 on the left and everything else is 0. And on the right, we have a multiplied by all those guys. So we're going to have ax to the fourth minus ax cubed plus ax squared minus ax plus a. And then we're going to have all of these guys multiplied by x plus 1. So I'm going to have plus bx to the fourth plus bx cubed plus cx cubed plus cx squared plus dx cubed plus dx squared plus ex plus e, and that's going to be our whole equation here. So we can just go through our solution here. So from this first equation, a is going to be negative b. We plug that in, so we plug negative a in for b. We're going to get c is equal to 2a. If c is equal to 2a, we have 3a plus d equals 0, so d is going to be negative 3a. d is negative 3a, so negative 3a minus a is negative 4a, so e is going to be 4a. And then from this last equation, we get 5a is equal to 1, which gives us a is equal to 1/5, b is equal to negative 1/5, c is equal to 2/5, d is equal to negative 3/5, and e is equal to 4/5. All right. So our whole purpose for going through that was to get this partial fraction decomposition. So we're going to go ahead and write that out. So our whole integral is now going to be equal to the integral of 1/5 over x plus 1 dx plus the integral of b. So you notice that all of these terms, I can pull out a 1/5. So I'm going to go ahead and do that. So I'm going to pull out actually a negative 1/5. And I'm going to get x cubed minus 2x squared plus 3x minus 4. And you notice all those change sign because I had the negative on the outside. And all of that's going to be over x to the 4th minus x cubed plus x squared minus x plus 1. All right. So what we notice right off the bat is that I can solve this left integral. So we're going to go ahead and pull that out. And this guy becomes the natural log of x plus 1 all divided by 5. Okay, so that's our first portion of our integral that's solved. I'm going to go ahead and star that, and we're going to come back to it later. For our second part, it's not quite as easy. So we look at this guy. We have a cubed term over a 4th degree polynomial. So we don't necessarily know exactly what we want to do here, but since I have 1 degree less in the numerator, what we could do is attempt some u substitution. So let's see what that looks like. So if I made u equal to x to the 4th minus x cubed plus x squared minus x plus 1, then du would be 4x cubed minus 3x squared plus 2x minus 1 dx. And I can make the top look more like that than it does currently. So let's look at this second integral now. I'm going to take this guy, and I'm going to have negative 1/5. Notice that du has a 4 next to x cubed. So I'm going to pull out a 1/4 and then multiply the inside by 4. So I'm going to get 4x cubed minus 8x squared plus 12x minus 16 all over x to the 4th minus x cubed plus x squared minus x plus 1 dx. Now, what I'm going to do is I'm going to make this top look like the du term. So let's go ahead and do that. I'm going to have negative 1 over 20 times the integral of 4x cubed, and this is all going to be over x to the 4th minus x cubed plus x squared minus x plus 1. But I'm going to separate this, and I'm going to have a term over here as well. So minus x cubed plus x squared minus x plus 1. And you notice that these are the exact same denominators. But what I'm going to do is instead of writing minus 8x squared, I'm going to write minus 3x squared here and negative 5x squared over here. And same thing for this. I'm going to, instead of doing plus 12x, I'm going to do plus 2x and do plus 10x over here. I'm going to have minus 1 and then minus 15 over here. Okay, so now I have, once again, 2 different integrals, and one of these integrals I can solve. So if I look at this guy right here, I can solve this integral, because now I have u and du on the top. So this is just going to be negative 1 over 20 times the natural log of x to the 4th minus x cubed plus x squared minus x plus 1. So now I'm left with just one more integral. So now I have this guy on the right, and I have to figure out what exactly I'm going to be doing with that guy. Okay, so let's go ahead and look at this integral over here. So this is my new subject. I'm going to go ahead and block off this other portion of the answer that I've arrived at, because I'm going to need to come back to that later. And let's look at this new integral. So I have negative 1 over 20, and I'm going to pull out a negative 5 from the top there. And now I'm going to have the integral of x squared plus 2x minus, let me check, I'm going to fix the signs in a second. So this is, since I took out a negative, it's going to be minus and plus. And in the denominator, I'll still have x to the 4th minus x cubed plus x squared minus x plus 1. Okay, so I'm getting places. I'm not quite there yet, but I look at this and I notice that I have a fourth degree term in the bottom, a second degree term in the top. It'd be nice if I could decrease this order of the denominator. I also notice that I have positive, negative, positive, negative, positive, all ones. So I'm going to see if I can do something here. So I'm going to see if I can reduce this order. So let's go ahead and look at this x to the fourth minus x cubed plus x squared minus x plus 1. And let's see if it would equal anything of the form ax squared plus bx plus c times dx squared plus ex plus f. And then because of the symmetry, I notice that a times d is going to equal 1 because my x to the fourth terms. And because of symmetry, I'm going to assume now that a is going to equal d. And that may or may not work out for me, but I'm going to make that assumption. And for the exact same reason, I'm going to look at the 1 terms in the f and the c, and I'm going to say c equals f, which is also going to equal 1. So I'm going to assume that a, c, d, and f are all 1. So let's go ahead and work through the rest of this right now. So we're going to end up with x squared plus bx plus 1 times x squared plus ex plus 1. Let's work through that. So that's going to be x to the fourth plus bx cubed plus x squared plus ex cubed plus bex squared plus ex plus x squared plus bx plus 1. And a bunch of these things are going to cancel between the left and right. So this x to the fourth and this x to the fourth go away. I have one of my x squareds will cancel out on the left and the right. I have a 1 that'll cancel out. And then I can come up with a few equations here. So let's look at my different equations similar to how I did above. So for my x fourth terms, those are all gone now. But for x cubed, I'm going to have negative 1 on the left, and on the right, I'm going to have b plus e. Okay, so I can simplify that and say b is equal to negative e minus 1. If I look at my x squared terms, I'm going to have a 0 on the left, and I'm going to have a be plus 1 on the right. So that tells me that be is equal to negative 1. And if I look at my x terms, I'm going to have a negative 1 on the left, and on the right, I'm going to have e plus b. And we notice that I don't get any new information out of that equation because this is the same as my first one. So let's go ahead and plug this equation in here. So I'm going to have e times negative e minus 1 is equal to negative 1. So I'm going to have e, factor out a negative from both sides, I'm going to have e squared plus e plus 1 is equal to 0. Let's double check my math right now. BE equals 1. So that's going to be a minus sign, sorry. I knew something was a little bit off. So let's go ahead and use our quadratic formula. So E is going to be negative 1 plus or minus the square root of 1 plus 4 over 2a. So we're going to have negative 1/2 plus or minus the square root of 5 over 2. All right, and if I look at that, I have BE is equal to 1. I also have B is equal to, this one's a little bit easier for us to see, this first equation. So that means B is going to be negative E minus 1. So negative E would be 1/2 plus or minus. Minus 1 would be negative 1/2. Then minus plus square root of 5 over 2. So I'm basically going to have the same thing with a different sign on the root 5 over 2 term. All right, so why did I do that? So what was I going through to find there? So the reason I did all of this was to figure out if I could factor my denominator up here, and it turns out we can. So that whole equation is then going to become 1/4 times the integral of something, so ax plus b over x squared plus my b term, -1 minus root 5 over 2. I'll do -1 plus root 5 over 2 over here, actually. So x plus 1 plus cx plus d. And these are different. I'm resetting my variables. So resetting a, b, c, d. I'm using a, b, c, d again just for simplicity of letters so that I'm not throwing out Greek letters. I know that confuses some people. Denominator, I'm going to have x squared plus -1 minus root 5 over 2, x plus 1. Okay, so you guessed it. We get to go ahead and do partial fraction decomposition again. So we get to solve for what a, b, c, and d are. So let's go ahead and do that. So on my left, I have, remember I'm going to pull it down from up here. So I have x squared minus 2x plus 3 was my original term. So let's look at my x squared terms. So for my x squared terms, I'm going to get, or x cubed, sorry. I'm going to get a, and I'm going to get c on the right side, and that's going to equal to 0 on my left, because there's nothing over here. For my x squared terms, I'm going to have -1 plus square root of 5 over 2 times c plus d plus b plus -1 minus root 5 over 2 times a is equal to 1, pulling that 1 from over here in front of the x squared term. For the x equation, I'm going to have -1 plus root 5 over 2 times d plus c plus a plus -1 minus root 5 over 2 times b is equal to -2. And for my x to 0 term, I'm going to get b plus d is equal to 3. Okay. And you can go back and look at where those come from if any of that's confusing. So from this equation, I can see that b is equal to 3 minus d. And from my first equation, I can see that a is equal to -c. Okay, so looking at my equations now, if I look at this second equation, I can see that -1 plus root 5 over 2 times c plus -1 minus root 5 over 2 times -c. So I'm multiplying this by -1, so I'm going to multiply that by that. So I'm substituting in a, -c equals a. So now I have these guys. So a few of these are going to cancel. So these ones cancel each other out. And I'm going to be left with 2 root 5 over 2, so which is just root 5. And this is going to be plus d plus b, which is 3 minus d. So I'm going to have a few more things cancel out. And that is all going to be equal to -2. Or sorry, that's equal to 1. I was using the wrong portion of my equation. Okay, so since that's equal to 1, I'm going to have root 5 c is equal to -2. So c is equal to -2 over root 5, which means that a is equal to 2 over square root of 5. All right, so I've solved for 2 of my variables. I can now pull out this x equation, and a and c cancel, so I'm going to be left with just my d and b terms. So I'm going to be left with negative 1 plus root 5 over 2 times d plus c and a cancel plus negative 1 minus root 5 over 2 times 3 minus d is equal to negative 2. So once again, I'm going to have negative 1 over 2 plus root 5 over 2 plus 1/2 plus root 5 over 2 times d, which is just going to give me root 5 d. And then now I'm going to have is going to be equal to negative 2 plus 3 over 2 plus root 5 plus 3 root 5 over 2. All right, so make sure I did that correctly here. Okay, so I come through, and if I add these up, I'm going to get root 5 times d is equal to negative 1/2 plus 3 root 5 over 2. And if I look at the other, so if I divide by root 5, I'm going to end up getting d is equal to negative root 5 plus 3, negative 1 plus 3 root 5 over 2 root 5. And we'll get a few things cancel out. Let me double check one little thing in my math real quick. We're going to get okay. I think that's okay. So now we get d equals negative 1 plus 3 root 5 over 2 root 5. If we want, we could separate that, and we would get negative 1 over 2 root 5 plus 3 halves. All right. And I could write that as negative root 5 over 10 if I wanted, but I don't mind having radicals in the denominator. Okay, so there's our first part, and then we have b is going to be equal to then 3 minus that. So 3 minus d is going to be 1 over 2 root 5 plus 3 over 2. Okay, so we notice that it's the conjugate of our first one. All right, so now we go ahead and plug those in. So now we're going to get it's equal to 1/4. And then we're going to have the integral of ax plus b, so 2 over square root of 5 times x plus b, which is 1 over 2 root 5 plus 3 halves. And that's going to be divided by x squared plus negative 1 plus root 5 over 2 x plus 1 plus, and then my b term, or my c term, is negative 2 over root 5 times x plus negative 1 over 2 root 5 plus 3 halves. And that is all over x squared plus negative 1 minus root 5 over 2 x plus 1 dx. All right, so at this point, we can go ahead and we have two that are in kind of a nicer format. So you'll notice that I have on the left second degree in the bottom and a first degree in the top, same on the right. So we can solve both of those guys now. So let's look at the bottom over here. So I'm going to have x squared plus -1 plus root 5 over 2 x plus 1. So the derivative of that is going to be 2x plus -1 plus root 5 over 2 dx. On the right side, it's going to be almost the same, so we'll name it v. It's going to be, v would be x squared plus -1 minus root 5 over 2 times x plus 1. So dv would then be 2x plus -1 minus root 5 over 2 dx. Okay, so we'd like to have these numerators up there. So what I'm going to do is I'm going to take 1 over 4 square root of 5 out of here. And that's going to leave me with the integral inside of 2x plus, and then what I'd like to have is -1 over 2 plus root 5 over 2. So we're going to have to do a little bit of math here. So if I want to pull that out, I'm going to get 2 plus -1/2. And then on the right side then, if I'm doing the same thing I did before, so if I, in the top I have plus 1/2 after I root. Actually, let's go ahead and write this out so that I'm not confusing anybody. So 2x plus 1 over 2 plus 3 root 5 over 2. And then on the bottom, I have the same thing, x squared plus -1 plus root 5 over 2x plus 1 dx plus 1 over 4 root 5. I'll pull out a negative. And up here, I'm going to have 2x minus 1/2, or plus 1/2 after I factor out the negative, minus 3 root 5 over 2. Okay, and that's going to be over x squared plus -1 minus root 5 over 2 x plus 1. All right, so now we can go ahead and get this to be in the right format. So on the left side, I'm going to have 1 over 4 root 5. Let's just look at this first integral. On the top, I'm going to have 2x plus, and remember we want -1/2, so let's make it minus 1/2. And then on the right side, we're going to have plus 1. So remember, we're just looking at the orange portion. So I'm going to go ahead and make this guy orange. All right. So we're subtracting 1/2, and then we're adding 1/2. And then we want to add root 5 over 2. So we're going to have plus root 5 over 2. And then on the right side, I'm going to have plus root 5. This is all going to be over x squared plus -1/2 plus root 5 over 2 x plus 1. And that's over the same thing, x squared plus -1/2 plus root 5 over 2 x plus 1. Okay, so now we're getting there. We're a little bit further along. So I noticed that I set this up in a specific way. So this guy over here, I set up so that it is 1 over 4 root 5 times the natural log of x squared plus -1/2 plus root 5 over 2 x plus 1. I'm going to mark that guy off and star him. And it turns out that, well, I'll work through that in a second. Okay, and then we're going to be left with this second integral that we still need to solve. And remember, it still has the 1 over 4 root 5, so I'm left with 1 over 4 root 5 times the integral of 1 plus root 5 over x squared plus negative 1/2 plus root 5 over 2 x plus 1 dx. So let's get this in the right format that we want. So let's fix that denominator. So if we fix the denominator, we're going to get 1 over 4 root 5 times the integral. And in the bottom, I'm going to want x plus negative 1 plus root 5 over 4, that whole quantity squared. And since I'm squaring this, recall that I'm going to end up getting negative 1, or I'm going to end up getting 1/16 plus 5/16 minus 2 root 5 over 4, which is 3/8 minus root 5 over 2. I'll go ahead and write that so I have the same denominator so I can divide it out a little bit. So that's going to be minus 4 root 5 over 8. And what I'm going to do now is I'm going to, since I have this in here, so this is going to be, I originally had the plus 1. So I'm going to have to, since I'm adding this in, I'm going to need to subtract it. So this is going to be plus 1 minus 3/8 plus 4 root 5 over 8. And all of that is still going to have the 1 plus root 5. So then I'm going to do a few things here. So first, I'm going to pull out that 1 plus root 5 from the numerator. And I'm going to end up getting 1 over 4 root 5 times 1 plus root 5. And I'm going to have the integral of 1 over, move this guy, x plus negative 1 plus root 5 over 4 quantity squared plus 5 plus 4 root 5 over 8 dx. So now just to get it in my standard format, let's go ahead and make this a little bit messier. So let's divide out, multiply the top and the bottom by 8 over 5 plus 4 root 5. So I'm going to get 8 over 4 root 5 times 1 plus root 5 times 5 plus 4 root 5. And then I'm going to have the integral of 1 over 8 over 5 plus 4 root 5 times x plus negative 1 plus root 5 over 4 squared plus 1. And then I'm going to go ahead and work through this. So what I notice here is that I can make my term here, this is an arctan, so I'm going to make this whole thing, my answer is going to end up being 8 over 4 root 5 times 1 plus root 5 times 5 plus 4 root 5 times arctan of the square root of 8 over 5 plus 4 root 5 times x plus negative 1 plus root 5 over 4 and then I notice here that I'm also going to have to multiply that by the square root of 5 plus 4 root 5 over 8. So that's going to come into play a little bit. So this whole thing, as ugly as it is, will end up being 1 over 4 root 5 times 1 plus square root of 5. And then on the top, I'm going to have the square root of 8 after those cancel. On the bottom, I'm going to have the square root of 5 plus 4 root 5 times arctan of the square root of 8 over 5 plus 4 root 5, so x plus negative 1 plus square root of 5 over 4. Okay, so this is now another piece in our puzzle. So we've now discovered kind of the last big piece. So we noticed that what we did up here, though, is we only solved the left portion. So we have not yet solved this right portion. Okay, but luckily, it ends up being pretty much the same formulation. So we get something that looks almost exactly like this, with just a different term right here when we do that step. And then when we come down here, we'll end up getting the same term here as well, except it'll be negative, and we'll end up getting a sign change on a few of our pieces. So I'll go ahead and refrain from going through all of that for the end. So we noticed that we had a few pieces. So we had this natural log up here, this other natural log. Then we came down, we solved for a third natural log and an arctan. And we can put all of those guys together. And our answer now is for the integral of 1 over x to the 5th plus 1 dx is now just 1/5 natural log of x plus 1 minus 1 over 20 times the natural log of x to the 4th minus x cubed plus x squared minus x plus 1 plus 1 over 4 root 5 times the natural log of x squared plus negative 1 plus root 5 over 2 x plus 1. Put the parentheses in the wrong spot. Minus 1 over 4 root 5 natural log of x squared plus negative 1 minus root 5 over 2 x plus 1. And then we're going to have these arctan terms. So then we're going to have plus root 8 over 4 root 5. It's 1 plus square root of 5, square root of 5 plus 4 root 5, arctan of the square root of 8 over 5 plus 4 root 5. Oops, I accidentally extended that up here. Times x plus negative 1 plus square root of 5 over 4. And then I'm going to have my last term, which is going to end up being negative square root of 8 over 4 square root of 5 times 1 plus square root of 5 times square root of 5 minus 4 square root of 5 arctan of the square root of 8 over 5 minus 4 square root of 5 times x plus negative 1 minus root 5 over 4. And that is our solution. So that nice clean solution at the end is what we get if we add that little 1 instead of just having 1 over x to the 5th. All right, well, thank you very much for joining me on this integral. I hope you enjoyed walking through this process. If you have your own problem that you'd like me to do and make a video for, please send it in. Otherwise, if you enjoyed this video, please like and subscribe. And as you're solving problems on your own, remember, think once, think twice, and always think thrice. Thank you.